if you have an interaction and it is significant, also here you will get one p-value and you have no clue what is different from what. So also for the interaction, you sometimes want to do post-hoc tests. How are they? Well, they are quite complicated to do. And how do you do them? Well, you need to start with this package, ls-means. There we are. And I'm just going to show you, and then it's easier to explain. Here we are. What is this function doing? Well, for each combination, here, for each combination of these two grouping variables, these two columns in my data, it is calculating the mean in that group. And it's not only calculating the mean, it's calculating the standard error and calculating a confidence interval for that mean. So for each group, I now have a mean and a confidence interval. I need this information to be able to compare the groups. You need the mean and the confidence interval. Okay. I'm going to do this, and again, I will explain. What am I doing here? I can also use this function to do all pairwise comparisons. For what? All pairwise comparisons for this interaction, the interaction of VS and AM. So he will make all possible comparisons of the groups that exist, and for these he will calculate a p-value. Yeah. So you see that, for instance, there is a clear difference in gas usage for groups with automatic transmission and VS0 compared to groups with manual transmission and VS1. And the same is true for these groups, and the same is true for these comparisons. Yeah? So if you want to compare everything to everything, every group to every other group, then you can do it like this, with this code. But very seldomly, this is what you want. So in the example that I gave, where you have control and treated, and males and females, the thing that you're most interested in will be the comparison of control and treatment for males and the comparison of control and treatment for females. Yeah, you always have a few favorite comparisons. So if you do not want to compare everything to everything, don't do it, because if you compare everything to everything, he's also going to correct for all these comparisons. So your correction will be more stringent when you do a lot of comparisons than when you just do a few comparisons. If you want to make specific comparisons, how does it work then? Well, again, you have to work via a contrast matrix. Yeah? How? Well, by using this function, the contrast function. It defines a contrast, a comparison that you want to do. You have to give him this here, the thing that I calculated. So for each group, he needs to know the mean and the confidence interval. So that is the input here. And then here in this list argument, you have to tell him which comparisons you want to make. Again, you see zeros and ones and a 1 and a -1. So this contrast works exactly the same as the contrast matrix that we defined for the one-way ANOVA. Every group is a column in this matrix. Yeah? So how does it work? Well, I'm going to check again how we defined it here. So we first defined VS. The first grouping variable in the formula is VS, and then comes the AM. So that means that the first two columns represent VS0. And the last two columns represent VS1. What is the difference between these two? Well, this represents VS0 and AM0, and the second one represents VS0 and AM1. So basically the same order as you see them appearing here. So this is the first column here. This is the second column here. This is the third column here. And this is the fourth column here. Yeah. So what are we ignoring? We are ignoring VS0. And I'm just giving a name for this comparison so I can know later on, that is what I have done. Yeah, so the list defines the comparisons that you want to make. If you want to make more than one comparison, you just add that to this list. You name a second one, and again you create a vector with zeros and 1 and -1. And here you say which method you want to use for multiple testing correction. So when I run this line of code, here we are, then for the contrast, the comparison that we defined, he will give you a p-value, a corrected p-value according to the method that you specified here.